Have you ever looked at an expression like 3x squared plus 2x minus 1 and wondered how to combine it with another polynomial? Many students make the mistake of trying to add terms that don't belong together. Today, we'll master the art of adding and subtracting polynomials correctly. Welcome to this comprehensive guide on adding and subtracting polynomials. By the end of this video, you'll confidently handle polynomial operations and avoid common pitfalls that trip up many students. First, what exactly is a polynomial? A polynomial is an algebraic expression made up of terms that contain variables, coefficients, and exponents, combined using addition and subtraction. This polynomial has three terms. Each term consists of a coefficient, which is the numerical part, a variable like x, and an exponent that tells us the power of the variable. Terms in a polynomial are separated by plus or minus signs. The key to adding and subtracting polynomials is understanding that we can only combine like terms, terms that have the same variable raised to the same power. When we add or subtract polynomials, we're essentially combining these algebraic expressions. The process involves identifying like terms and combining their coefficients while keeping the variable parts unchanged. In the upcoming sections, we'll explore the different types of polynomials, learn systematic methods for addition and subtraction, and work through detailed examples that will build your confidence and mastery of these essential algebraic skills. Before we can add and subtract polynomials effectively, we need to understand the fundamental building blocks. Every polynomial is made up of terms, and understanding what makes terms alike or different is crucial for success. This polynomial contains 6 separate terms. A term is any part of a polynomial that is separated by addition or subtraction signs. Let me show you how to identify each term clearly. Now let's examine what makes up a single term. Every term has 3 possible components: a coefficient, which is the numerical part, a variable, which is usually a letter like x or y, and an exponent, which tells us the power of the variable. The coefficient is the number in front of the variable. In this case, it's 3. The variable is x, and the exponent is 2, which means x is raised to the second power. If there's no visible number in front of a variable, the coefficient is understood to be 1. Now comes the most important concept for adding and subtracting polynomials: like terms. Like terms are terms that have exactly the same variable raised to exactly the same power. The coefficients can be different, but the variable part must be identical. In contrast, these terms are not like terms because they have different variables or different exponents. Even though they might look similar, we cannot combine them directly when adding or subtracting polynomials. The key rule to remember is this: only like terms can be combined when adding or subtracting polynomials. This is because like terms represent the same type of quantity. For example, 3x squared plus 2x squared equals 5x squared, just like 3 apples plus 2 apples equals 5 apples. Understanding these fundamental concepts, terms, coefficients, variables, exponents, and like terms, is essential for successfully adding and subtracting polynomials. In the next section, we'll explore how to classify different types of polynomials based on the number of terms they contain. Now that we understand what polynomials are and how to identify their terms, we can classify polynomials based on how many terms they contain. This classification system helps us organize and work with different types of polynomial expressions more effectively. Polynomials are classified into 3 main categories based on the number of terms they contain. A monomial has exactly 1 term, a binomial has exactly 2 terms, and a trinomial has exactly 3 terms. A monomial is a polynomial with exactly 1 term. The term can be a constant number, a variable, or a product of constants and variables with positive integer exponents. A binomial is a polynomial with exactly 2 terms connected by addition or subtraction. The terms are separated by a plus or minus sign. A trinomial is a polynomial with exactly 3 terms. These are commonly seen in quadratic expressions and other polynomial forms. In addition to classifying polynomials by the number of terms, we also classify them by their degree. The degree of a polynomial is the highest power of the variable in any term. Consider this polynomial: 3x to the 4th power plus 2x squared minus x plus 5. To find the degree, we look at each term and identify the highest exponent. The first term, 3x to the 4th, has degree 4. The second term, 2x squared, has degree 2. The third term, negative x, has degree 1. The constant term 5 has degree 0. Since the highest exponent is 4, this polynomial has degree 4. The degree is always determined by the term with the largest exponent. Now practice identifying polynomial types and degrees with these examples. We'll examine each polynomial and determine both its classification by terms and its degree. The polynomial 7x to the power of 3 is a monomial with degree 3. The polynomial 2x minus 5 is a binomial with degree 1. The polynomial x to the power of 2 plus 3x minus 2 is a trinomial with degree 2. The polynomial 4x to the power of 5 minus x to the power of 3 plus 2x minus 1 is a polynomial with degree 5. Remember that polynomials with 4 or more terms are simply called polynomials, without a special name. The key is to count the terms carefully and identify the highest degree to classify any polynomial expression correctly. Now that we understand polynomial basics, we can learn how to add polynomials. There are two main methods we can use: the horizontal method and the vertical method. The key to adding polynomials is understanding that we can only combine like terms. Like terms have the same variable raised to the same power. The horizontal method involves writing the polynomials side by side and then grouping like terms together. Here's our first example. Step 1, we remove the parentheses. Since we're adding, all the signs stay the same. Step 2, we identify and group like terms. The x squared terms are in red, the x terms are in green, and the constant terms are in purple. Step 3, we combine the coefficients of like terms. 2x squared plus 1x squared, 3x minus 1x, and 1 plus 4. Our final answer is 3x squared plus 2x plus 5. Now let's solve the same problem using the vertical method. This method aligns like terms in columns, making it easier to see which terms to combine. We write the first polynomial on top, then align the second polynomial below it so that like terms are in the same column. Now we add each column. In the first column, we have 2x squared plus 1x squared, which equals 3x squared. In the second column, we have 3x plus negative 1x, which equals 2x. In the third column, we have 1 plus 4, which equals 5. Our final answer is the same, 3x squared plus 2x plus 5. Both methods give us the same result. The horizontal method works well for simple polynomials, while the vertical method is more organized for complex polynomials with many terms. The important thing to remember is that both methods will always give you the same correct answer. I recommend practicing both methods so you can choose the one that works best for each problem you encounter. Now we'll work through our first example of adding polynomials step by step. This will help you see exactly how the process works in practice. Here's our problem. We need to add the polynomial 4x squared plus 2x minus 1 to the polynomial 3x squared minus 5x plus 6. Step 1. We remove the parentheses and write all terms horizontally. Since we're adding, we can simply remove the parentheses. This gives us 4x squared plus 2x minus 1 plus 3x squared minus 5x plus 6. Step 2. Now we identify and group the like terms. The x squared terms are 4x squared and 3x squared. The x terms are 2x and negative 5x. The constant terms are negative 1 and positive 6. Now we'll combine each group of like terms by adding their coefficients. Step 3. We combine each group of like terms. For the x squared terms, 4x squared plus 3x squared equals 7x squared. For the x terms, 2x plus negative 5x equals negative 3x. Remember to be careful with the signs here. For the constant terms, negative 1 plus 6 equals positive 5. Now we can write our final answer by combining all the simplified terms. Our final answer is 7x squared minus 3x plus 5. Notice how we've successfully combined all like terms and maintained the correct signs throughout the process. The key takeaway from this example is to always pay careful attention to the signs when combining terms. This is where most students make mistakes, so take your time and double-check your work. Great job working through this first example. You now understand the step-by-step process for adding polynomials using the horizontal method. Now we'll work through a more complex subtraction problem using the vertical method. This approach helps us stay organized when dealing with polynomials that have multiple terms. Here's our problem. We need to subtract the second polynomial from the first polynomial. Notice that this problem has terms with different degrees, including a missing x squared term in the first polynomial. Step 1. We must distribute the negative sign to every term in the second polynomial. This means we multiply each term by -1, which changes all the signs. When we distribute the negative sign, positive 2x cubed becomes negative 2x cubed, positive x squared becomes negative x squared, and negative 5 becomes positive 5. Step 2. We arrange the polynomials vertically, aligning like terms in columns. Notice that we need to use 0 as a placeholder for missing terms to keep everything properly aligned. The 0 placeholders are crucial. They help us keep the x squared terms and x terms in their proper columns, preventing alignment errors that could lead to wrong answers. Step 3. Now we combine like terms in each column. We'll work from left to right, starting with the x cubed terms, then x squared, then x, and finally the constant terms. First column, 7x cubed plus negative 2x cubed equals 5x cubed. Second column, 0x squared plus negative x squared equals negative x squared. Third column, negative 2x plus 0x equals negative 2x. Fourth column, 4 plus 5 equals 9. Now we can write our final answer by combining all the results from each column. Our final answer is 5x cubed minus x squared minus 2x plus 9. Notice how the vertical method with 0 placeholders kept everything organized and prevented errors. This systematic approach is especially helpful with complex polynomials. Remember, the key to success with the vertical method is using 0 placeholders for missing terms and carefully combining like terms in each column. This prevents the common mistake of misaligning terms with different degrees. Now that we've mastered the techniques of adding and subtracting polynomials, you might be wondering where these skills actually apply in the real world. The truth is, polynomials are everywhere around us, from the buildings we live in to the technology we use daily. In architecture and construction, professionals constantly use polynomials to calculate areas and volumes of complex shapes. When an architect designs a building with multiple sections, they add polynomial expressions representing each area to find the total space. For example, if one section of a building has area 2x squared plus 5x plus 3, and another section has area x squared minus 2x plus 7, the architect adds these polynomials to get the total area of 3x squared plus 3x plus 10 square units. Engineers use polynomials extensively in motion and force equations. When analyzing the movement of objects, engineers often need to combine multiple polynomial functions representing different forces or motions acting on a system. Here, if an object's position is described by adding two motion functions, we combine 3t squared plus 2t plus 1 with negative t squared plus 4t minus 2 to get the total position function of 2t squared plus 6t minus 1. In business, polynomial functions represent cost, revenue, and profit relationships. Companies use polynomial addition and subtraction to analyze their financial performance and make strategic decisions. For instance, if revenue is 5x squared plus 100x and costs are 2x squared plus 50x plus 1000, then profit equals revenue minus costs, giving us 3x squared plus 50x minus 1000. Now that you've seen how important these skills are in the real world, here are my top tips for mastering polynomial addition and subtraction. Tip number 1. Always write your expressions in fully expanded form before combining like terms. This prevents you from missing terms or making sign errors. For example, expand 3x times the quantity x plus 2 before adding it to other terms. Tip number 2. Take time to carefully identify and group like terms before combining them. Use color coding or underlining to keep track of terms with the same variables and exponents. Group the x squared terms together, the x terms together, and the constants together. Tip number 3. Regular practice with focused attention is key to mastering these skills. Start with simple problems and gradually increase complexity. Spend just 10 to 15 minutes daily practicing, and always review your work to catch and learn from common mistakes. You now have all the tools you need to succeed with polynomial addition and subtraction. Remember that these skills connect to real careers and real-world problem solving. Keep practicing, Stay confident, and you'll master these concepts in no time. Polynomials truly are everywhere in the world around you.